So, I've been looking around. I was reading through lithium isotopes, started looking around. Then at some point, I went back to the map to kind of get an idea. Because essentially, last I talked about was this kind of thing. I was definitely, I'm feeling pretty good about this. Like, this is what's happening. So, this right here, I'm pretty sure is represented extremely well by what I just posted here. This is a on the earth representation of this. And I was just looking around and I was looking at Tahiti here and I was thinking, well, based on what I was drawing here, there's kind of an inlet here that goes around. So anytime there's a shape like this, there tends to be an inlet at like a point there. And I was looking at Tahiti like, maybe this island. And so I thought, well, is there an inlet here? And I looked at it. Like, there's a bunch of them. For sure, there's a bunch of them. I think this is maybe reminiscent of how polygons can have many polygons. But, like, there's what looks to be a legitimate inlet right here that was, like, carving this way, pushing this way, leading to this like structure here, and then two outlets. So if I go to helium, wait, one channel, two channels, that's right. Helium just becomes two channels, but lithium becomes like this, and I was thinking maybe it shifts so that like this as these split, they become more like evenly distributed and arranged to an equilibrium. Something more eternal. Like this is not yet balanced. Like something more like, okay, it is balanced. Let's just draw it with a sure. Like this, maybe here as an inlet with more here. And then because it has two outlets, I mean, I'm kind of leaning towards that island, obviously. But I'm thinking like, what if? So like, one, two, three neutrons that kind of become more like one another as the currents kind of shape them, assuming the currents keep flowing to shape them. It's just what's going on. Help, please, please, guys. This way, out this way, and then also this way. So kind of separating around each one and just going around. I mean, maybe like one neutron, two neutrons, three neutrons. Maybe I'm drawing them a little too big. And then one proton, two protons. And this maybe closed off somehow by filling up here to have 4 protons. Like this is more like a lithium atom, lithium 7. So what I was just drawing, let's go back here. This maybe is more like a lithium 6. But then it can have a 7, so maybe it does like the island does. It's got 1, 2, 3, but then kind of forms like a mass here to like not completely block it off, but essentially block off the current so that it's like more stable. And then the current just flows kind of maybe more like this and like this, with just a little trickles this way and this kind of thing, like maybe somewhat more to the top side, but let's see if that makes any sense. Let's draw this. Let's write lithium 7. Oh. Lithium 7. Does that look like we have formed that island? Honestly, it's not the worst explanation for this island. Because this over here, I was thinking, like, there's some chemistry here. This might be a lithium atom representation. They're not all, like, if this is, by the way, if this is lithium, like, this could still represent hydrogen on a different scale better than it represents other things. Although it probably doesn't. Like, it probably represents something even better than hydrogen. I'm just pointing that out, like, because it is kind of square. It looks like it's maybe even like 4 bonds, like a carbon atom. Who knows? I haven't really thought about this. But this looks like a good progress. So, I mean, I feel pretty good about this potential. That there's just a big open space that forms when it stabilizes here, so then it just has like just a mass that kind of, maybe it's not exactly like a particle, it's more distributed, but it just causes enough current flow blockage to make lithium 7 a little more stable than lithium 6, because this just doesn't, currents just flow too easily and can break the polygon walls, and then the particle basically degrades to a different, it decays. So like, I wrote some things down. Red also, so like lithium glows red. I was wondering maybe that means something to do, like, if we heat it, maybe it's normally like this is the direction of flow, but if we heat it, maybe we can change the current direction so that like the inlet becomes the outlet. And so effectively it begins to merge all of its outlets begin to feed back into it, which then emit from a single point. And I was wondering if maybe it's like its wavelength depends on its outlet slit opening. Okay, with that in mind, let's move on. Okay. Sufficient heat can cause, okay. But then I saw alpha particles quickly pick up electrons to become helium, so it's almost like, to go back to helium, like there's something like this going on, and then the inlet just gets blocked off, and like the pressure builds, and so it pretty much severs this and causes it to be emitted, but then the flow has just been kind of draining because there's no inlet, but there's still an outlet, so it's just draining pretty much. And so it is emitted as an alpha particle without the internal electron current flow that's been draining, and then it quickly is refilled when it's emitted, and the opening allows for current flow back into it because the pressure finds the path of least resistance. It goes right through that same place that was the path of least resistance. And so it follows that way and reopens it and becomes a high helium atom. Thought that was maybe feasible. High surface area lithium sheets in water explode, and I was thinking that the currents flow through in a way that cause like novas, so like tangential flows in some way. Maybe that's useful. Does not oxidize above 300 degrees Celsius in air. So there's that, which probably would suggest that, like, not this, lithium. Lithium does not oxidize above 300 degrees Celsius in air. So that's probably useful to consider that maybe what's going on is like oxidation is to, like, there's a channel here and it causes a blockage, an energetic bond between the two. So above a certain temperature, like the back pressure essentially can be high enough where the bond just doesn't form. Maybe something of that nature goes on. Small amount of lithium-6 produced in stars and radioactive. Let me find it. I think it was here. Produced in stars in the Big Bang. Produced by nuclear reactions in certain stars. So I'm not sure what they meant by this, and I didn't bother to find out. But I figured that it probably was suggestive of like the fact that what's occurring is it's puncturing the tritium. So if we go back to tritium, like it starts with just a container, and then it forms a like bodies within it, but then it forms tritium, and then it punctures this. And so, like, if it punctures this and becomes helium-2 4, then, and just keeps cycling through like the things and up to lithium then next. Like maybe it just kind of jumps lithium-7 because it kind of it's more like moving into the equilibrium zone like this. Not quite equilibrium, more equilibrium. But if there's an increasing current causing the system to evolve to new equilibriums, it's not going to bother to form this particle. It's just going to move up to the next atom. So I figure that might be relevant in that. I'm not sure if that's what they were saying. Yeah, so that's some thoughts I was having. I thought I'd record it, and I'll be back with more. Making some progress on chemistry, I do believe, if I do say so myself. See you guys soon.